Okay, so let's just recap what we need to be able to sketch quadratic functions. So we should always have the turning point, and you need to state whether it's a maximum, which is a graph that looks like this, or a minimum, which is a graph that looks like this. We need the Y-intercept, and that happens when x is 0. And we also need the line of symmetry, which is the x coordinate of turning point. Okay, so let's take this one for example. We need to list down the turning point. Now, it's in turning point form. So remember, the turning point is the opposite of the bracket, so it's +2 at the moment. So it is -2, and then whatever's added on the end. So -2. So this is your x, and this is the y. Okay, so our turning point is -2, -2. Now, because there's no negative out the front here, where the yellow is, that means that it is a graph that looks like this, therefore being a minimum. Okay? Our line of symmetry is x equals -2 because it matches the x coordinate of the turning point. And our y-intercept we need to find, so that's when x is 0. Now if we put 0 into our equation, we get 0 plus 2 all squared, take 2, which becomes 2 squared, which is 4, take 2. Therefore, the y-intercept happens at 0, 2. So if we were to sketch this now just mind my sketch because I'm doing this with my finger. We set up our axes. You guys should use a ruler. We label our axes y and x, and we need to put these 3 things on our graph. So our turning point is at -2, -2. So we go across to -2 and down to -2, and we put a dot. Put a dot just there for the turning point. We then also have our y-intercept at 0, 2. So we go up to 2 here, and we put a dot there as well. Now, if we've gone across to this way to get up to 2, we need to go across to this way to go up to 2 here. And we put a dot as well because our graph needs to be symmetrical. We then draw a line, curve through our dots that looks sort of like that, bearing in mind I'm using my finger. So then we label our turning point, -2, -2, and our y-intercept, which is 0, 2. And with a ruler and the same colour, I'm going to use a different one just so you can see. You would also draw in the line of symmetry with a dotted line and label it as x equals -2. And that's our sketch done. Obviously yours will look a lot neater than what mine is. Okay, so we have our second example here, y equals -x plus 4 all squared plus 1. We get our turning point by just simply looking at the opposite of the bracket. So the opposite of +4 is -4, and whatever's added on the end, which is +1. So our turning point is -4, 1. Now this time, if you look where the yellow is, we have a negative out the front. That means that our graph is now this shape, meaning it is a maximum turning point. Our line of symmetry, again, easy, it's right there in front of you. It should be -4 because these two things should match. And lastly, our y-intercept is when x is 0. So when x is 0, we put in to our equation, we've got the negative out the front, which means -1. And we have 0 plus 4 all squared plus 1. Now, negative out the front, so then we've got 4 squared is 16. So it actually becomes -16 plus 1. So our y-intercept is 0, -15. When we draw a sketch, we need to draw our axes again. Again, you guys need to use a ruler. We label them, and we need to put these three things on the graph. So our turning point is at -4, 1. So we label 1, and we label -4. Might just shift that over a bit so you can see the other point. So -4. Okay, so we put a dot at -4, 1. And that there is our turning point. We also have our y-intercept at 0, -15. So if we go right down to here to -15, our y-intercept, is going to be here. Now, we've gone 4 this way to go down 15, which means we need to go 4 this way to go down to 15. So we're actually at -8 now. And we go down to -15 here. Now again, you need to draw in your curve. Yours will look a lot nicer than mine, hopefully. That one's not too bad. So we label our turning point. We've got -4, 1, and our y-intercept, which is 0, -15. We draw in our line of symmetry. Again, you guys just use the same colour. I'm just doing it for you to be able to see, as x equals -4. Okay, so our final example here is in standard form. So this time it's a little bit harder to get our turning point, and we can't actually get our turning point first. The first thing we need to do is our line of symmetry using the formula -b over 2 times a. Okay, b is here, and a is here. Okay, now obviously there's no number in front of the x squared, but we know that that's actually a 1. So when we do our line of symmetry, we've got -6 over 2 times 1, which becomes -6 over 2. Therefore, our line of symmetry is at -3. So x equals -3 for our line of symmetry. To find our turning point, we already know that it's -3 something. We need to sub it back into the original equation. So we do y equals -3 squared plus 6 times -3 plus 8. So we get 9, take 18 plus 8. 9 take 18 is -9. -9 plus 8 is -1. So our turning point is -3, -1. Okay, so we've got the line of symmetry and the turning point. We just need to get the y-intercept now. Now the y-intercept, again, when x equals 0, so we have y equals 0 squared plus 6 times 0 plus 8. Therefore, it equals 8, so our y-intercept is 0, 8. To draw our sketch, we need to put those things on the graph now. So we've got our turning point at -3, -1. So we label those two things, and we put a dot there where the turning point would be. Our y-intercept is at 0, 8, so we label 8, and we put a dot at 8 as well. Now we've gone across 3 to go up 8, so we need to go across 3 to go up 8, which means it's at -6. And up to 8, so we put a dot there. And we have our graph again. So we go through there like that. Obviously, that one was not as good. If we just look back at our turning point and our first line of symmetry, if we look here at, just in the blue, I'm underlining it, the coefficient of x squared here is a positive, which means the turning point is still a minimum because the graph will be this shape, okay, which is what we got in the end. So just remember to label your turning point and your y-intercept. Good luck and have fun sketching your graphs.